Hey there, I'm Matto, and welcome back to Devlog 3 for Hypercastle Explorers, our project where we are looking to build a Unity game engine SDK which interacts with the Terraforms by Mathcastles NFT project. Let's get started. So, welcome back. What we've been working on for the past couple of weeks is, first of all, we completed the animation rendering that we needed to do, and there was a little bit of kind of complex font wrangling because the Mathcastles SVG files are rendered with a custom onchain font. It's a kind of a custom ASCII art focused font. There was some funny stuff with the Unicode parsing that we had to do so that we could render the full range of animations, right? Because if you're familiar with Terraforms, there is the kind of basic set of animations, but then as you get into certain rarer parts of the collection, there are these kind of extended animations with more character cycling, with scaling of the character values, and some kind of more esoteric animation that only happens for a smaller number of characters. So we left it for a little later in the process, but is now done and is in the repo. And now we kind of get to the fun part, which is starting to broaden out and to start thinking about the kind of demo portion of the SDK, right? So the SDK portion, which allows us to read data from the contract, resimulate it the way that the SVG output looks, for example, on OpenSea, that is basically done, right? So we're now able to kind of one-to-one replicate the 2D SVG outputs of the Terraforms contract in Unity. We also wrote a little bit of user interface for scraping the data from the contract, right? So that is also in the project, so you can choose to scrape a range of tokens or scrape all the tokens, and that brings it down and puts it into its own C# based data structure, which includes things like the height map indices for each token, but also some of the on-chain metadata like the zone and the X and Y coordinates and stuff for people who are going to want to work with that data. And so the kind of base level SDK functionality of being able to pull in the raw data, resimulate it in 2D is basically done. But of course, the point of doing that is to do more stuff and cool stuff and different stuff with that data, right? Which is what we're able to get started on now that we've kind of got the basics done. And so there are kind of two parallel threads that we're splitting into to do that. One is the 2D demo that we're building, which is going to be very faithful to the existing Terraforms artwork, basically re-rendering them in the game engine and then kind of making a reference to classic roguelike games. We're going to have a little @ text character that moves around the map. Terraforms have a real thematic reference to the kind of world of generative ASCII art games, which is the roguelike genre, right? In speaking with Exaltgeist, one of the developers, he's a fan of Dwarf Fortress, which is probably the kind of towering masterpiece of that genre created by Tarn Adams. Check it out if you don't know about it. So there's some clear resonances with the Terraforms project in the sense that it's heavily procedural and it's ASCII art based. And so we're going to kind of reference that in our 2D thing. We're going to make an @ character that moves around on this grid and uses the Terraform artwork as a map, and you're kind of blocked by certain more fixed kind of mountain-like structures, and you can move through some of the flowing spaces that are kind of more fluid and animated. And there's also going to be a little kind of quote-unquote airship mode. That's one of the references in the contract, which in my opinion is a Final Fantasy reference, right, where you can get into this airship and fly around the world map. Effectively what it does is lets you fly in the air and ignore collision. Because the Terraforms procedural generation code is basically Perlin noise, it doesn't have any kind of concept of allowing contiguous walkable spaces for the player, which is something you'd normally put some care into in a video game, right, to make sure that you're not creating impassable zones. Because that doesn't exist, we're going to create this flying mechanic so that you can always get to the next tile or the next place that you want to get to. Now, the really cool thing that I actually just saw yesterday and that I'm really excited about is the some of the rendering optimization that one of the developers on our team has done, which is allowing us to generate a custom 3D mesh, which uses a custom 2D renderer and allows us to draw the entire terraform, each frame, in one draw call. For those of you who know 3D graphics, you know that this is cool and sometimes difficult. A draw call is basically the game engine marshals together everything that needs to be rendered on the CPU side and packages it up to pass to the GPU, right, the graphics processing unit, which is the fast rendering tech in a computer, and passes it over to be rendered. Right now, the number of draw calls that you have per frame is very highly correlated with your frame rate, right? Very often in modern video games, that is the limiting factor on how fast your game can be rendered. And traditionally, the kind of minimum that we want to render at is 30 frames per second, but a kind of a desirable frame rate that looks smooth and beautiful is around 60 frames per second. If you're rendering at 60 frames per second, that means you have 16 milliseconds every frame, or 16.66 milliseconds every frame to do all the work that you need to do, right? Lest you miss the deadline and drop a frame and the game slows down, right? So your frame rate dips. So what that means, our ability to render an entire terraform in a single draw call, is that we are able to render one terraform in one frame in 0.1 milliseconds, right? A tenth of a millisecond. So what that means then is that we are going to be able to render 160 terraforms per frame at a frame rate of 60 FPS, right? So this, you know, you could tell this is exciting. This is exciting to me. Being able to draw lots of things really fast enables all kinds of interesting gameplay and creative possibilities. So I'm super proud of our team for getting this done. And so what that means then is that we're going to be able to do some interesting stuff in the 2D rendering mode, right? Originally, I was thinking that we would need to keep the camera quite close and only render a few terraforms at a time. But now, if we want to, we go into airship mode and we can fly the camera way up and look at a 40 by 40 grid of terraforms and see them all animating and rendering at 60 frames a second, right? So we're currently using Unity's job system to draw each parcel as one mesh. Previously, when we used the TextMesh Pro components, we were drawing each glyph in a grid separately, which meant that we had 1,024 individual meshes being drawn, which is 1,024 draw calls. Instead of telling the GPU to draw 1,024 glyphs individually, we now create one mesh that contains all the glyphs and characters, and we tell the GPU to draw that. And then, since we can determine the total number of characters at any point in time, we can parallelize the mesh construction. Each job processes 32 characters at a time and subsequently processes 128 vertices and 192 indices simultaneously. Super excited about that and excited to share that code, open source that code for everybody. The other thread that's going on is that we are getting ready to build the 3D visualization. And that is going to be the more complex and probably more interpretive and more creative part of the project for our team, because we're going from a 2D work to a 3D work. There's going to be some interesting creative challenges there and some technical challenges, right? Because again, we're going to be rendering a lot of these things, and ideally we want to have a situation where you can move the camera around freely, see big chunks of this structure. That's something that we're working on. The first step to that was just recreating the Hypercastle structure using the data from the contract that we're pulling off of the EVM, right? And then re-rendering that in 3D using the structure space coordinates. What this looks like looks very, very similar to the original work that kind of got me started in all this stuff, my animation, the long view that I did back in December, but in that case I was using a JSON data source that was scraped out of the contract by somebody else, which now we are able to do based on the scraped data from the contract. And one thing that we did just for fun was to set up some animation that cycles each cube through the different zone colors of the zone that it represents. So in the 3D structure, each token or each Terraform parcel is represented by a single cube, which has a zone with a color palette associated with it. And so what we're doing is just animating and cycling through the colors in the zone on the cubes, just to make it look a little bit more like the Terraforms themselves. We're actually going to use that 3D data in rendering the 2D landscape, just displaying it in 2D one level at a time. But for the level layouts, right, the relationships of each token to one another, we're going to be using that same data source. On the non-development side of the project, there's a few updates. One is that we did the first airdrop for our token holders, which is a set of 12 video-based NFTs, which are extracts from the long view animation that I mentioned, and those went to the people who minted the DVD case looking Hypercastle Explorers tokens, which have the images of the long view incorporated in it. So there are 15 of those in total. 3 of them are not yet minted, which is kind of interesting. So if you're somebody who likes the idea of getting airdropped one of those one-of-one video NFTs created by me, well, you can go and mint from the contract. There's still maybe 80 that are not minted yet. Of course, we're very appreciative if you choose to do that. We also released a new exhibition on JPEG, the website that you can find at jpeg.space, which is a gallery exhibition protocol platform for creating exhibitions of NFTs. I did one a couple of weeks ago about Terraforms in general with a bunch of text that kind of explains the context around the project, also some of the meaning, right, what I think it means. And for the Hypercastle Explorers exhibition, I tried to break down the creative process of creating the token art a little bit. So I actually talk a little bit about how we sampled the Terraforms, how we chose which pieces to include, the procedural generation process of creating the artwork in the Unity game engine. So if you're interested in how that art was created and some of the thinking behind it, please do check that out. I'll make sure there's a link in the video description. And then in some unconfirmed, kind of slightly rumorish, but cool news, we've had some outreach from another NFT project that I'm a big fan of, which is called Tiger Bob, which is being created by the artist Gossamer Rosen. Gossamer is actually someone who I met through the Terraforms community and became a real fan of their work. They do tattoo art, fine art, and also some textile-based work, which is really beautiful. And Tiger Bob is their own NFT collection, and it's 1,000 of these pixel tiger heads, which are hand-drawn, not procedural, and are generating a lot of attention and excitement and are really beautiful. And Gossamer has expressed an interest in building some kind of game-like experience on Terraforms. So obviously the work that we're doing on Hypercastle Explorers is relevant. So nothing is confirmed. It's just, you know, some conversation in Discord, but I would be really, really excited, both because I love Gossamer's work and just to have somebody who's got some great artistic vision coming in and using some of the work that we've created and open sourced for Hypercastle Explorers. So hopefully something will develop out of that, but that's a cool kind of first milestone for us, having somebody looking at and thinking about building with the code that we're building. So super, super psyched to see that. And yeah, that is the kind of, you know, basics of everything that's been going on. It's actually quite a lot. So if you are enjoying these videos and you want to be notified when new ones come out, please consider subscribing. We appreciate that very much. Drop a like on the video for the YouTube algorithm and leave me a comment. What do you think? Are you excited to see more? Are you interested? Do you think this is totally boring? Let me know. And yeah, as always, just thanks so much